Math Mentor back with another lesson on the remainder and factor theorem. Watch and learn. Consider 7 divided by 3. The result is 2 remainder 1. In this equation, we call 7 the dividend, 3 the divisor, 2 the quotient, and 1 the remainder. Notice that 7 can be written as 3 times 2 plus 1. That is, dividend is equal to divisor times quotient plus remainder. Now, taking this knowledge to polynomials, let the polynomial p of x be the dividend, x minus k the divisor, q of x the quotient, and r the remainder. From above, we can write p of x is equal to x minus k into q of x plus r. This is the remainder theorem and states that when p of x is divided by x minus k until a constant remainder r is obtained, then p of k is equal to r. To prove this, consider p of x is equal to x minus k into q of x plus r. Substituting x is equal to k, we obtain p of k is equal to k minus k into q of x plus r. Notice that the first term on the right hand side, k minus k, simplifies to 0, so p of k is equal to r. In order to understand this properly, we need to know the definitions of zeros and roots of an equation. The zero of a polynomial is the value of the variable which makes the polynomial equal to 0. Meanwhile, the roots of a polynomial are simply the zeros of that polynomial. For example, the polynomial p of x is equal to x minus 5 into x plus 1 into x minus 1. The zeros are positive 5, negative 1, and positive 1. These values can be obtained by solving the equation using the null factor law. Example: use the remainder theorem to find the remainder when x raised to the power 4 minus 3x squared plus x minus 4 is divided by x plus 2. Let p of x be equal to x raised to the power 4 minus 3x squared plus x minus 4. I am dividing by x plus 2, so the zero of x plus 2 is negative 2. Applying the remainder theorem, we ensure that p of negative 2 is equal to the remainder. So, substituting negative 2 into p of x, we obtain simplifying gives 34. So, the remainder when p of x is divided by x plus 2 is 34. Notice that we have obtained the remainder without performing long division. Now moving on to the factor theorem. Consider the division of 8 divided by 4, which is 2 remainder 0. We say that 4 is a factor of 8 because it divides 8 exactly, written 4 times 2. The factor theorem can be stated thus: f of x has a factor x minus k if and only if f of k is equal to 0. To prove this theorem, we follow the same procedure as the case with the remainder theorem. Example: show that x minus 2 is a factor of p of x where p of x is equal to x cubed plus 3x squared minus 13x plus 6. The zero of x minus 2 is positive 2. So, apply the factor theorem. We substitute positive 2 into p of x, obtaining simplifying, we get plus 12 minus 26 plus 6, which is equal to 0. Hence, x minus 2 is a factor of p of x. We can equally use the combination of both theorems to solve problems. Example of such is 2x minus 1 is a factor of f of x, where f of x is equal to 4x cubed minus 4x squared plus ax plus b. And the remainder when f of x is divided by x minus 1 is negative 1. Find values of a and b. In this question, we will be applying both the factor theorem and the remainder theorem. 2x minus 1 is the divisor of f of x and also a factor. Its 0 is equal to half. This can be obtained by simply solving the equation 2x minus 1 is equal to 0. Substituting half into f of x, we obtain 4 into half cubed minus 4 into half squared plus a into half plus b is equal to 0. Simplifying gives half a plus b is equal to half. Now multiplying both sides of the equation or each term by 2 simplifies to a plus 2b is equal to 1. We can call this equation equation 1. Next, we can apply the remainder theorem. The 0 of x minus 1 is equal to positive 1. So substituting positive 1 into f of x, we obtain f of 1 is equal to negative 1, which simplifies to 4 minus 4 plus a plus b is equal to negative 1. So a plus b is equal to negative 1. We can call this equation 2. Solving equation 1 and equation 2 gives b is equal to 2 and a is equal to negative 3. I have made a complete lesson on solving simultaneous linear equations. If you didn't watch, the link is present in this video's description. In some cases, a polynomial of degree 3 can be given and then asked to factorize completely and eventually find the root. This method above may not be useful. Instead, we need to perform long division. In the subsequent lesson, I will explain how to perform algebraic division or long division. Stay tuned, like and subscribe to the channel. Equally share the video to your friends. Thanks for watching.